Teak 2A is in the linear category, and it talks about domain and range. Then the student is expected to determine the domain and range of a linear function in mathematical problems, determine reasonable domain and range values for real-world situations, both continuous and discrete, and represent domain and range using inequalities. Now this is a big and wordy teak, so let me break it down a little bit for us and understand what it is. Domain and range is really just talking about where the function appears on a graph. That's the easiest way we can think about it. And we're given 3 different situations we have to know about, and they're all answered differently. In our first example here, this is called a discrete example. It's discrete because these are discontinuous information. They're dots, just plotted points. And we want to give an information about where these dots show up in our coordinate plane along our x-axis and along our y-axis. Domain is talking about the x values and range is talking about the y's. So to list this discrete data's domain and range, all I have to do is write down the x values where a dot appears. So we have a dot right here. The x value is -2. We have a dot here. Its x value or x coordinate is a -1. This dot, its coordinate is 0. We have a coordinate at 1, a coordinate at 2, and a coordinate at 3. So our domain should have all of those numbers listed. -2, -1, 0, 1, 2, and 3. Those are all of the x values that are used in this discrete example. Now range is going to be very similar, it's just the opposite. So instead of looking at the x values, the range is going to be looking at the y values. These are the list of y value outputs for the coordinates on this graph. So this coordinate right here, starting at the bottom, because we always want to list it from smallest to largest, this coordinate, though it has a domain of 3, its range is -3. So we put -3 in our list. Our next coordinate appears at -2 for its y value. -2 goes on my list. The next 2 dots are at the same height, at the same output, at the same y value. So 0, or no height up or down, appears on my list only once. It's a list, we don't have to put it on there more than one time. The next coordinate as we're going up appears at level 2, and the next coordinate at the highest point occurs at the output of 3. So it creates my list of range coordinates. And when we're going to get to continuous examples, these are lines that are connected. Continuous means connected. We have line segments and we have lines. Now these are very similar, but we're going to have a slight difference between them depending on whether they're bounded, meaning it has endpoints, or unbounded, which means it doesn't have endpoints. Sometimes you'll see arrows at the end indicating that graph is going on. This graphing software I use didn't indicate with arrows. We just know it's going to keep going because it's a continuous graph. So for domain and range in continuous, we don't just list things because there's a whole bunch of tiny little numbers in between on that line that we aren't going to sit here and list. They're infinitesimally small. But what we will do is list the numbers from smallest to largest and the domain and the range that goes between them. So I notice right here on the left, the smallest number that I can go to the left is right here. It's an open circle that appears at -1. Now an open circle is an exclusive symbol, meaning we can't include -1. So it's anything that's going to be to the right of it or greater than -1. So we would use the symbol -1 less than x, which is the same mathematical sentence as saying x is bigger than -1. Okay, so we have our left number. We're going to look on the right. On the far right side, the biggest number in my domain that this graph is going to go to appears at 2, but it's a closed circle. That's an inclusive symbol, which means we can include 2 in our answer. So instead of just using a less than symbol, I'm going to use now the less than or equal to symbol because it can be exactly 2. Not included, included. So we would have our domain as the x values, this direction, x values between -1 exclusive, less than, and 2 inclusive, less than or equal to. This is a proper inequality format for this domain and range, or for its domain. The range, we're going to look from the bottom to top, still going smallest to largest. When we're looking up and down, smaller is on the bottom. Same thing. The bottom digit here is at -2 exclusive, not including -2, so we don't put the line underneath our symbol. We have -2 less than a y. Range is always the y's. Then we go up and we follow it along to the very, very tip top, and the very tip top appears at 4 inclusive, so we use less than or equal to 4. These are the most common ways you're going to be seeing domain and range. Perhaps they're one-sided inequalities, but this is the inequality notation that's used in Algebra 1 and is stated in our TEAC. Now, the last version of a continuous is an unbounded continuous graph, and that's again the one that's going to have maybe arrows on either side indicating that it keeps going on and on and on forever and ever. My graphing software did not indicate that, but we understand that lines continue until you have a stopping point. So if I ask the same questions I did for domain in the other one, if we can go to the very beginning, on the very far left, as far as we can go, can I ever reach an ending point? No, because this line is going to keep going and going and going and going. Okay, so we're going to say it starts at negative infinity. Okay, we'll write that down. Negative infinity. And if we look along the right side, as it goes up, on and on and on and on, is it ever going to stop on that side? No, we can't find the very far right point. We can't find a left point, we can't find a right point. So we're going to consider that to be infinity. Now the thing is, in Algebra 1, we're not going to include the infinity symbols in our answers. So instead of saying negative infinity to positive infinity in this format like we did for the bounded version, we're just going to say all real numbers. That's indicating from the first number that has been invented ever to the last number that's been invented ever. From negative infinity to positive infinity, this graph shows up there. It shows up everywhere. We're never going to have it stop somewhere from the left to the right. Now, range is very similar here. We're still looking at the y values, which are from the bottom to the top. So I can do a lot of the same concepts in the range that I do domain. Now, domain, I was looking this direction. Range, I'm going to be looking this direction for a starting point down at the bottom. In the bounded version, we had an open circle, maybe a closed circle. We don't have that here. It's going to be starting at, again, negative infinity along my y-axis, all the way down here. Look at the top. Does the top ever stop? We can't find an ending point at the top because it's going to keep going forever. So we're going to say that that ends at positive infinity. Same rule matters, though. We can't include infinity signs in our inequalities for Algebra 1, so we use the phrase all real numbers, indicating that every number from negative infinity to positive infinity, this graph shows up there. So this graph is continuous in 4 directions. This direction, that direction, this direction, and that direction. It goes on forever in both ways. That ends up being 4 different directions. Now, this is a hard concept, so we have a few acronyms we use in class to help our students remember. Dr. XY is our very first acronym. That's one of my favorites because a lot of times this will eliminate half the answer choices. If the question asks about domain, the answer choice has to have an X in it. If the question asks about range, the answer choice has to have a Y in it. If it doesn't have the correct variable in the inequality answer, don't pick that one. You're answering the wrong question. Okay, the second thing we teach kids about is called Dolor the robot. Most importantly, because domain addresses graphs from the left to the right. That's smallest to largest. That's how we want to list our data, is how we want to write our inequalities. Smallest to largest, which is left to right. Robot, again, since that's range and it's Y, it's going to go from the bottom to the top, which is getting our smallest to largest indicator in there. So Dolor the robot, very helpful to remember what domain and range is talking about. So an example question, we're going to do a couple of these. It says a student worked out at the gym continuously for 50 minutes. The graph shows the remaining percentage of the workout as a linear function of x, the time in minutes. So here we have our graph. Okay, if we look at some things on here, it's the student's workout. This is the percentage remaining of the workout of time, and here's the minutes that they've been working out. Cool, so it looks like they had this much left in their workout as they're going. Which answer choice best describes the domain and range of the function for the situation? So we would tell students to write down on their paper Dr. XY, because we're asking both about the domain and about the range. So we want to make sure we're answering both questions here. This is not one that can eliminate answer choices right away based on the letter, but it is very important to understand what the question is asking. Now, we can eliminate half the answers here. If you look at B and D, these 2 answer choices here are talking about the graph showing up in one spot, one coordinate. That's it. The only input I have is -2, and the only output I have is 100. Or the only input I have is 100, and the output I have is -2. That doesn't make any sense. We have a whole line here. Okay, so we're not going to have a single answer. We're going to have a mathematical sentence, either in words or in mathematical symbols. So we can go ahead and eliminate those. We know that that's not right. That's for a discrete graph, those dots, and this is a continuous graph. And right there, I have 50% chance of getting this right. So let's read our answer choices, shall we? It says, the letter A says, the domain is all real numbers, down here, okay. Our domain is all real numbers greater than or equal to 0, check, and less than or equal to 100. Well, if this is 50, that means 100 would be here-ish on my graph. Did I go all the way to 100? Doesn't seem right. Let's read the range and make sure. The range says all real numbers greater than or equal to 0. Yeah, we're greater than 0. And less than or equal to 50. Does my graph stop here for my range? No, that has gotten them mixed up. Okay, so we're going to eliminate answer choice A because we don't think that's right. And we're going to read answer choice C, which says the domain is all real numbers greater than or equal to 0. Yeah, we start at 0. And less than or equal to 50. We ended at 50. And it's a closed dot on both, so that's why we're allowed to say or equal to. Sounds good. Let's check the range. So the range is all real numbers greater than or equal to 0. Here's the bottom. It's at 0. Yep. And less than or equal to 100. Yeah, the top is at 100. So that sentence, it's written in English and not mathematical symbols, is exactly the inequality that we want to express the domain and range of this graph. This is exactly where it shows up. From 0 to 100 in my, 0 to 50 in my domain, and 0 to 100 in my range. Our second example here is a discrete example, just to show you a little bit of the difference between a continuous and a discrete example. And it says, a set of weights includes a 4-pound barbell and 6 pairs of weight plates. Each pair of plates weighs 20 pounds. If X pairs of plates are added to the barbell, the total weight of the barbell and plates in pounds can be represented by this function, f of x equal to 20x plus 4. Okay, let's take a second and figure out what's happening here, because if we don't understand what a barbell is, we're stuck. A barbell is talking about the thing that you put weights on. And you lift, okay? Or I guess lift. Yes. And so we're saying we can add more and more plates to change the weight, which makes sense. And this right here is the function that we can model this adding of weights. So if we want to add 20 pounds every time, the barbell is started out at 4. That's what this graph is, or this equation is telling me. Now the question says, what is the range of the function? We see range, we think Dr. XY, and we know we're talking about the outputs, not the inputs, not how many weight plates I can put on there, but the output, how much weight it is. Now it says we have 6 total pairs of weight plates, so that's how many we can put in. That's not what we're getting out. We don't want the in data, we want the out data. So let's eliminate some answer choices. If we put nothing on the bar, okay, so if we're putting a 0 right here for X, my output, which is what I care about, 20 times 0 is 0, 0 plus 4 is 4, which means my first number in my answer choice should be a 4. Therefore, I can get rid of 2 answer choices. Right there, by knowing I'm wanting the outputs, not the inputs, I've gotten rid of half of my answers. This happens a lot with these kinds of questions. Now we just need to figure out which one of these appropriately models adding different plates to it. So if we put 1 pair of weight plates on here, so instead of just a 0, we're going to plug in a 1. 20 times 1 pair of weight plates is 20 pounds, plus 4 would be 24. Which means the next number in my list of outputs should be 24. Well, I have that here, but I don't have that there. This is skipping some of the weight plates. It's not a range of my entire function like this one would be, which goes up by 20 each time when I'm adding weight plates to this barbell. So we would say that this is not correct, and we would choose answer choice B. Now, an important note here is this is one of the most important skills needed before heading up to higher level math classes. Even for our math class, we're going to do domain and range for every type of function that we learn, which in this class is 3 different functions. In Algebra 2, you learn about 8 different functions. Every time you learn a new function, we're going to talk about its boundaries, its domain, and its range. So right now, understanding this in a linear context is going to be the easiest and most accessible way to understand it. This is really something we want to concentrate on. It's one of our most important skills. As always, remember, we empower, we impact, we love, we are Skeeter Nation.